Greetings, everyone. This is the Chapter 9 review for the test. I'm just going to go over a few of these angles and then some of the other problems, and hopefully that will be of help to you. As always, I recommend you do the problems first before I go over them. Make sure you exhaust all of your problem-solving skills before you look at the solution. Don't just dive into what I have to say. So make sure you try on your own first. Okay, so I'm not going to do all of these, but let's just do maybe 1 radian and 1 degree. So if I want to convert this into a radian, for example, this negative 220 degrees here, all I have to do is multiply by pi over 180 degrees. And unfortunately, this one is not on the unit circle. It's not a classic angle. So in this case, I really have to multiply by pi over 180. So this ends up being minus 220 pi over 180. And that could be a little bit difficult to simplify. And so what I recommend is just maybe you don't simplify the whole thing at once. Maybe you just try to take out what you can. So for example, I can see that both numbers are divisible by 10. So I know that this is minus 22 pi over 180, over 18. Because if I just divide top and bottom by 10, I would get negative 22 pi over 18. And then I notice that they're both even, so I can still divide by 2, so I get minus 11 pi over 9. And I happen to know that 11 is prime, which tells me that there's nothing that can simplify, and it certainly does not share any factors with 9. And so this is it. Notice I also did not convert to a positive angle because it didn't ask me to. If it asked me to, I would, but it didn't ask me, so I'm not going to. This is as simple as it gets. Do not give me pi as an approximation, 3.14, some decimal. Don't do that. Just leave it as pi. Let's go let's do number 4, 3 pi over 5. So if you go the other way around, if you want to go from radians to degrees, you just have to multiply it by 180 degrees over pi. Notice that it's opposite of the one before. And notice also that the pi's will cancel it. So that way I remember, oh, I have to put this pi in the denominator because it has to cancel with the pi in the numerator. And this way, I know that I'm going to end up with a pure degree without any pi's in it. And also, before you go and multiply 180 by 3, just remember my rule to simplify before you multiply. So actually, you should divide by 5 before you multiply by 3. So 180 degrees divided by 5, you can use long division if you don't have a calculator, or if you're not allowed to use a calculator, more likely. And so if I divide this by 5, it goes into 18 3 times. 3 times 5 is 15. Subtract that from 18, and I get 3. I'll just kind of messed up my 3 there. That's a horrible 3. And then I bring down the 0, and 30 divided by 5 is 6. 6 times 5 is 30, and that leaves me no remainder. So therefore, it is 36. And I'm running out of, I kind of painted myself into a corner here. Maybe I can change the color. This will be 36 times 3. I really did paint myself into a corner. Let's do this down here. 3 times 36 degrees, which will be 180. Okay, moving on. Number 5. Again, please do the problem before you watch me solving it. Now, for this test, we actually only need the other 2. We're not going to deal with secant, cosecant, cotangent. We're just going to deal with sine, cosine, and tangent, so that's all I'm going to stick with. But let's have a look at our unit circle. I'm not going to go to the unit circle. I'll just kind of sketch you one real quick. So here on my unit circle, sine is -1/2. Remember, sine is the y value. So that means that it's approximately here and here on your unit circle. This will be the 330 degree mark, let me change the color so we can have some contrast. That'll be about 330, and that'll be about 210. If you just look, and the way you know that is if you have your unit circle, which I'm assuming you do, you can just look where the sine of theta is -1/2. And so you're going to find that it's in these points right here. And what you'll see if you look at your unit circle is that this coordinate here is square root of 3/2, comma, -1/2. And the one on the other side is just like it, except that the cosine will be negative. So we have negative square root of 3/2, comma, -1/2. And they didn't ask for the one on the left. They only want to know where the sine of theta is -1/2, and then the cosine is also positive. So the sine is -1/2 for both of these, but the cosine is positive only for the one on the right. And that's what makes this one the correct point to look at. This is the actual theta. What this means is that theta equals 330 degrees. Or if you prefer in pi radians, 11 pi over 6. And you can just look at the unit circle, and now you know what the cosine is there. The cosine has to be this one over here. It has to be this one here is the cosine. And so cosine equals √3/2. And then the other question will be, what is the tangent? So in other words, what is the tangent of 11 pi over 6? And of course, if you remember, that's just the sine divided by the cosine. So this is the sine of 11 pi over 6, which we already know what it is, but I'll still write it like this, just so you can see where I got it from. Divided by the cosine of 11 pi over 6, which we also now know. But again, I'm writing this for your benefit so that you can solve future problems. And then we just replace what we know. So we know that the sine of theta is -1/2. Now let me actually use a different color. I want something that is different from the others. So I have here the sine of theta is -1/2. That 2 kind of got smushed. So this is -1/2 for the sine. And then remember, the cosine is this one here. It's square root of 3/2. So we're going to divide this by square root of 3/2. And now we're ready to simplify. So if you remember how to handle division by fractions, you remember that what you have to do is you have to take that fraction in the numerator. I don't know why I did it like that. And then multiply by the reciprocal of the denominator. In other words, we're going to take that √3/2 from the denominator and flip it. And we multiply it by that fraction that was in the numerator there. And what this will give us is, well, these 2's are going to cancel and simplify. And we're going to get -1 over the square root of 3. And you might be tempted to say we're done, except that we're not allowed to have a square root in the denominator. So therefore, we will multiply this by what will resolve the denominator, which has to be square root of 3, because in the denominator, the square root of 3 times the square root of 3 will be multiplied with 3. And this way we have a denominator. I'm running out of space. I'm still going to go for it. And the numerator will then be -√3. Negative didn't show up. Here it is. Paint it into a corner again. Here it is a little bit better. There you go. This is my answer for the tangent. Okay, moving on. Again, I don't have time to do all of these. I think people struggled more with number 7, although the one on the left is also negative. I think I can do both. So they want to know the exact value of the sine of theta, and also the reference angle. So in other words, none of this negative stuff and none of this over 2 pi stuff. So I can convert this to a positive angle, or if you are familiar with your unit circle, you can also look to see. Well, this came up in class where some people didn't quite get what that reference angle would be, and so normally I would say, well, we just add 2 pi. So I can say that this is 2 pi minus 5 pi over 6. But then some people didn't like having to convert the 2 pi with the denominator, but I'll do it anyway, and then we can talk about another way to do it. So this is 12 pi over 6, right, because 2 pi is 12 pi over 6, minus 5 pi over 6. And now I get that this is 7 pi over 6. So that is the reference angle. And that means that this right here, this angle, is 7 pi over 6. And now, again, if we have our unit circle, that's really nice because that's one of them that's on there. And at 7 pi over 6, the sign is negative a half. Yay. Another way of doing this is, well, is there really a better way? If you like degrees, you could convert to degrees by looking at what 5 pi over 6 is 150 degrees, and then subtract 150 from 360 if you prefer to do it that way. That's acceptable, but you know, it's a little bit out of your way. Let's go on to the next one. So let's circle the answer just so that we're clear here. The sine of theta is negative a half, because at this point right here, this is negative root 3 over 2, comma, negative 1/2. And as I always say, the cosine's on the left, the sine is on the right. The cosine is the x value, the sine is the y value. So the sine is negative a half at that point with this angle that was given. Okay, number 7. 9 pi over 4. Well, as you can see from the rotation, it went all the way around and then a little bit more. And if you know that 2 pi, if you can just convert 2 pi and change the fraction, change the denominator, you can just say, well, this is 9 pi minus 8 pi over 4, because 8 pi over 4 is 2 pi. And this leaves me with pi over 4, so I have my reference angle. And then you just look at your unit circle, and you see, oh, at pi over 4, you know, here's my unit circle. That's a horrible unit circle. But at this point, I know that it's root 2 over 2, comma root 2 over 2, but I don't care about the rest. Fine, I'll do it just for the heck of it. And we know then that the cosine is root 2 over 2. So I have my reference angle here, and I have root 2 over 2. I'm trying to think if there's another way that you might want to do it, but I think that's really what you need. Okay, so let's move on to these here. I'm only gonna do one of these so that we can keep this video a little bit shorter. So this one's very similar to the one earlier. So, you know, I should really stick to doing this, and then we're going to draw a circle. The sine is negative square root of 3 over 2. So let's draw those dots approximately where they are. Just look at your unit circle. And if you look at your unit circle, you'll see that they're about here. And I will draw a line to connect them to the center. I could actually measure the angle if I wanted to be exact. That's okay. And you'll notice if you look at your unit circle that this point here is 1/2, comma, negative root 3 over 2. And this point here is negative 1/2, comma, negative root 3 over 2. And what is the angle that it corresponds to? So if you see this on your unit circle, then you should just look at the angle that it corresponds to, and you'll see that this one here says 240 degrees, and this one here says 300 degrees. And so it also gives you the radians. And since they want to know both, that means that theta has to be either, and I'll put the radians here. So this is 4 pi over 3, and this one here is 5 pi over 3. And so that's what theta is going to have to be. Theta is going to have to be 4 pi over 3 or 5 pi over 3. And those are the answers. Make sure you get both answers. You can't give me just one, because look what they said. They said in the between 0 and 2 pi. So anywhere on the circle where the sine of 30 is negative root 3 over 2, any point that has that, that's what you need to include. So make sure that you have this in your solution set. Let's move on. Make sure we got this. Again, try this one before I show you what to do. We need to transform this. Now, ordinarily, a sine function starts at 0 and then goes up. So at pi over 2, right about in the middle, goes up, then to pi. Then at 3 pi over 2, it goes to negative 1. And then over there, it goes like that. And that would be a normal sine function, meaning like the parent function without any transformations. But this is going to be moved up by 1. So what I like to do is I like to draw the midline. So I'll actually go to 1 and I'll try to draw this all the way through. And this is going to be my midline. And I'm basically going to take this sine wave and I'm going to, now I have to fix the amplitude. Now I actually think this is kind of getting in my way. So let's dispense with this. And now our sine wave, it not only is moved up, it also has an amplitude of 3, which is, of course, the a value, the number in front of the function, in front of the sinusoidal function. And so at 0, if you input 0 for theta, you would get an output of 1. And of course you do, because the midline got moved up. And if you input a value of pi over 2, so that would be approximately here, pi over 2, you would get a value. So normally you would get 1, but because it's multiplied by 3, you would get 3, and of course that's added to 1, so we would get a point up here at 4. And then at pi, it would go back to being at 0, plus 1 is 1. And then down here at 3 pi over 2, if you plug 3 pi over 2 into the sine function, you get negative 1, and negative 1 times 3 is negative 3, plus 1 is negative 2. So we're going to plot this point here at negative 2, and 3 pi over 2, comma negative 2. And then if you plug in 2 pi, the sine of 2 pi is 0, 0 times 3 is 0, 0 plus 1 is 1, so you end up here. And so if we just kind of connect the dots in the way that we know sine functions go, I'm going to make a really rough sketch, which for me is not half bad. And so notice, please, that the amplitude is 3 because the distance, if you drop down a height here, this distance is 3 from the maximum to the midline is 3. And that's why the amplitude here is 3. So the amplitude is 3. The vertical shift was 1. The phase shift, there was no phase shift because there was nothing here next to the theta inside the parentheses. And radians, there was also no change. There was no coefficient to the theta, so there was no way that was shifted. In case you're wondering what that would be, if you have a coefficient to the theta, I would call that the b value, and you would have to take 2 pi over b, and that would give you the period. But it didn't come up in this one, so we lucked out. But just so you know, for the test, that's how it would go. And our final question is, can we write a possible equation for this graph? Well, let's find out a few things and just go through this methodically. First, let's do the midline. The midline is here, and as you can see, this midline is at -3. So this means that my k, sometimes people call it d, is -3. You can also say that this line here is y equals -3. And I'm just going to write the basic parent function, y equals sine of x, and then we can fill in the things, or sine of theta, and then we can fill in stuff. So this is -3, so let me use a different color here. Since I did purple, I'll make this purple. So this is -3. And let's check out the other things. Let's check out the amplitude. So the amplitude, of course, is the distance between the maximum and the midline, which appears to be 2. So this is going to be the a value, which is in front of the sine function. So that's my coefficient. So the amplitude is 2. The period, well, let's see what a period is. My unofficial plain English way of saying it is one hill and one valley. Of course, we talked about how it is graphed by going around the unit circle, and it plots all the y values of the unit circle, with the input being the theta. And that's a very technical term, a way of explaining, but also accurate and necessary. But for my classes, I found people like it when I say, oh, one hill and one valley is one period. Of course, that doesn't work for trig functions like that, but it's good enough for us here. And we can see that the period is actually still just 2 pi. In other words, nothing has happened to it. So in other words, we don't need any coefficient on theta. And also, if we look at the phase shift now, was it moved at all from 0 to 2 pi? No, it seems to go up from the midline and then resolve the period by the end of 2 pi. So nothing was shifted left or right. So we did not have anything inside these parentheses, if you want to have parentheses here. So in other words, we're done. So this is what the equation would be for this graph. I'd like to thank you for paying attention. Again, I hope that you went over these before I explained it. Review any homework and make sure you have a good sheet of notes and that you know your unit circle inside and out. Thank you very much.